In this video we're going to discuss enolates, how to make them and how to use them. The simplest enolate formation is just to do it in water. You take a ketone like this, throw it in aqueous base, you'll indeed get a mixture of enolates. Unfortunately, this is not terribly useful because this hydroxide simply isn't strong enough. pKa of a ketone is 19, water's like 16, that's a difference of 3, so at the best you got about 1/1000th of your ketone in the enolate form. Plus you get a mixture of enolates. So for synthesis, this would be terrible. So what we do is we leave water. So let's just get rid of this stuff, get rid of these products, get rid of the equilibrium arrow, get rid of the hydroxide, and let's go to a better base. What base are we going to use? Well, we're going to use LDA. Come over here to the Oscar menu. Here's LDA. What is LDA? Let me draw the structure down here. LDA is the lithium salt of diisopropylamine. So diisopropyl, here's one isopropyl group, here's the second one, and we're going to form an anion of it. It's going to be the lithium salt. So here's the anion, and we need a lithium cation. So this is LDA. Oops. This is LDA. It's a very strong base. The pKa of an amine is like it's going to give you this is going to give you a pKa of about 25 or so, actually 30, and the anion therefore is much stronger than that of hydroxide, and it's plenty strong enough to deprotonate the ketone. Now the other unique feature about this is that this base is very sterically hindered. These isopropyl groups really get in the way. So it's always going to go for the side of the ketone with the less steric hindrance. In this case, the methyl group is a lot smaller than the ethyl group. So the LDA will go for the methyl group. So if we ask Oscar to give us our product, it immediately gives us the product where we form the enolate on the least hindered side. Now we have a lithium enolate. Well, these things you essentially can form quantitatively, 100%. And the nice thing is you can use them as reagents. You can do an alkylation. So let's just take a simple bromide, simple primary bromide. I don't know, let's do a propyl group. Here's a propyl, oops, switch to carbon. Here's a propyl group, hit the magic button, and we've alkylated. So this propyl group, these last 3 carbons have been added onto the methyl of the original ketone. You can see this can be really useful. Your alkylating group can be more complicated. I can, let me put a phenyl on here. So I'll put a phenyl out here, and so now we have this crazy compound. Do the reaction again, and as you see, we've now added this group to our lithium ones. Can you use any bromide? Well, only primary, benzylic, or allylic. What you can't do is secondary or tertiary. Why not? Well, let's just try it. So let me make up here a secondary bromide. So here I'll take this and I'll add some more carbon. So now I got a secondary bromide. What if we try to do the reaction now? Oh, look at this. Oscar just gave us 2 elimination products. The problem is, you remember that these enolates are pretty strong bases. Remember, this had a pKa of 19. So this is a strong base, and indeed it sees this bromide when secondary elimination will beat substitution. So you can only do this alkylation with a primary alkyl halide or benzylic or allylic. But it's a great reaction. And what you're going to do is to alkylate the least hindered side of your ketone. In the next video, I'll show you a trick that allows you to enolate or make an enolate on the other side and alkylate there.